Hey guys, so we are going to start a new topic this week called sequences, and we're going to look at two different types of sequences. When I say sequence, I'm talking about a list of numbers in a specific order. So those numbers may be related by addition or subtraction or multiplication and division. And another vocab term I wanted to introduce you to is term, and that's referring to each number in the sequence. So if I say the third term, that would be the third number in the sequence, or the fourth term, that would be the fourth number in the sequence. So just keep that in mind while we're looking at these sequences. All right. So here's an example of a sequence. And the first type of sequence we're going to look at is called arithmetic. I know it looks like arithmetic, but in this case, it's pronounced arithmetic. And that is when the numbers in the sequence are related by addition or subtraction. So 4, 9, 14, 19, 24. So the pattern here is that every single time we get the new number, it is increased by 5. From 4 to 9, we increase by 5. From 9 to 14, we increase by 5. 14 to 19, and 19 to 24. Each time they're increased by 5. So because that's a constant number of increase or decrease, this is considered an arithmetic sequence. There are obviously other types of sequences that we'll look at in a little bit. So how can you tell if a sequence is arithmetic? Well, we can check to see if the number that's being added or subtracted is constant. So if we look at this first example, to get from 2 to 4, that's increased by 2. From 4 to 8, that's increased by 4. And then from 8 to 16, that's increased by 8. So you'll notice that that number of increase is not the same. So this would not be an arithmetic sequence. Now, if we look at the second one, from 48 to 45, that's decreased by 3. 45 to 42 is decreased by 3, and 42 to 39 is decreased by 3. So since it is the exact same decrease each time, we would consider this sequence arithmetic. So we were given a sequence and we're asked to find the next 3 terms, and it's telling me that the sequence is arithmetic. So I know that I need to keep my next 3 terms the same increase or decrease. So let's see what that is. So from 2 to 5, that would be added by 3. From 5 to 8, add by 3. 8 to 11, add by 3. And 11 to 14, add by 3. So if we keep up that pattern, the next number would be 17, then 20, and then 23. So we could do it that way. Another thing that we could do is there are actually formulas to be able to find different numbers in a sequence. There's 2 categories of formulas. So I'm going to talk about this first category, which is the recursive formula. Recursive means that it's based on the previous number. And that's helpful when we're talking about like maybe the first, second, or third number of the sequence. But if you're talking about like the 100th number of a sequence, then it starts to get a little bit more difficult to find that recursive formula. But this is what it is. It says a sub n, which is just referring to any number in the sequence. I don't want you to get confused by the like labels here. That's just saying any number of the sequence, I can take the previous number and add the common difference. Now that common difference could be a positive if we're adding numbers, or it could be a negative where we're subtracting numbers. So that is just saying I could take the number before and either add or subtract that difference to find the next number. In my opinion, the more useful version is the explicit formula. So we have any number, we're basing it on the first number, that's what a sub 1 is, the first term, and we're taking whatever term we want, subtracting by 1, and multiplying it by that common difference. So for example, if I was trying to find the 60th term, this number right here would be 60 minus 1, which is 59, and we'll do a couple of examples. Okay, so let's look at some examples of these sequences and finding these 2 formulas. So here's a sequence. 2, 4, 6, 8, and 10. So we're going to find the recursive first. And remember, the recursive formula refers to any number, so we're going to call that a sub n. And we could take the previous number, a sub n minus 1, and what's happening each time. So if we are looking from one term to the next term, forget from 2 to 4, that would be plus 2. 4 to 6 would also be plus 2, 6 to 8 would be plus 2, 8 to 10 would also be plus 2. So when we're talking about this formula, we are going to add 2 each time. Now, again, this isn't as useful as the explicit formula because we always have to base it on the previous term. So let's look at the explicit formula. Which says a sub n, and remember the next part is a1. So what is the first term in the sequence? The first term of the sequence is 2, and then we want to add n minus 1, and then we want to multiply that by what's called our common difference, or the number that's being added or subtracted each time. In this case, remember that number is 2. So I'm actually going to show you an example of what that looks like on a graph. I hope by now you realize it's increasing by a constant rate. So the kind of graph that it should make, hopefully you remember, is linear. So here is that exact graph, linear. And you'll notice that our first term, remember, was 2. Our second term was 4. Our third term was 6. And our fourth term was 8. And we could actually use this graph to figure out any term in the sequence. So if I go back here, what would happen if, say, I wanted to find the 45th term in the sequence? So I'm trying to find A45. I would still have my 2 plus 45 minus 1 times 2. So 45 minus 1 would be 44. 44 times 2 would be 88, and 88 times 2 would be 90. So that would be the 90th term in the sequence. Now we could also use the recursive formula here, but we would also need to know the 44th term in order to get the 45th term. So the explicit formula is just a little bit more useful when we're trying to find those higher numbered terms. Okay, so let's try this one. So we want to write the recursive and explicit. So recursive would be a sub n equals a sub n minus 1. And if we look each time to get from 7 to 11, it's adding 4, then adding 4, then adding 4. And then our explicit formula is still a sub n, but we're basing it on the first term. So the first term is 7 plus our n minus 1, and we're multiplying that by 4. So those are our 2 different types of formulas we can use for these sequences. Okay, so here's another one. So 10, 4, -2, -8. So let's first concentrate on the recursive formula. So remember, we're taking any term. We can take the previous term, and each time, this one's actually not adding, we're actually subtracting, and we're subtracting by 6. You may also see this written as a sub n minus 1 plus -6, but I usually just write it as a subtraction problem. That second part is asking us to find the explicit formula. So let's do that. A sub n equals our first term, which is 10, plus n minus 1 times that minus or -6. And then part C is actually asking us to find a term in the sequence. We're trying to find that 42nd term. So A42 equals 10 plus 42 minus 1 times -6. And I'm going to be a little cheater here and get out my calculator. So 42 minus 1 is obviously 41. We want to times that by -6. And that would be -246. So 10 plus -246, 10 plus -246 would be -236. So that would be the 42nd term in the sequence. We would just substitute in 42 for that n value. Okay, so let's look at a few more. So let's get rid of this calculator for now. This next question is a word problem. So suppose you've saved $75 towards the purchase of a new iPad. You plan to save at least $12 from mowing your neighbor's yard each week. In all, what is the minimum amount of money you will have in 26 weeks? So we're going to use the explicit formula here. So when we're trying to find any number, we want to use the first term, which is that original $75, plus the previous term times 12. That 12 is that difference. I'm increasing my money by $12 each week. So if we're trying to find the 26th term, we have 75 plus 26 minus 1 times that 12. So again, let me grab my calculator here. So 26 minus 1 would obviously be 25 times that 12 plus my original $75. So I would end up with $375 after 26 weeks, and that's half of a year. And I'm pretty sure iPads are a little bit more expensive than that, but that's a good start. So $375 would be how much you would have after those 26 weeks. Okay, the last question I want to look at is sometimes you will see figures when we're talking about arithmetic sequences. So here's a couple of figures. So each side of the squares has the length of 1 unit. A1 represents the area of this first figure. So 1 times 1 would obviously be 1 block. The area of this one is obviously 4. A2 represents the area of the second figure. The area of this one is 7 blocks. And we want to know what it would be the rule for the nth block. So how many blocks are we increasing by each time? So we're going from 1, and then we have 4. So from 1 to 4 would be plus 3 blocks. This one would be plus 3 blocks. I believe this is 10, so this would be also plus 3 blocks. Our fourth figure would be 10. So if we're talking about the recursive formula, all we're doing is we're taking the previous term and we are adding 3. So that would be letter C. All right, so if you have any questions, again, don't hesitate to contact me through email or Remind, and I look forward to hearing from you guys.